Okay, number 8 says find the height of the giraffe in the diagram below. Well, and it's nice because it gives you pictures already. Okay, so let's set this up in a proportion. Okay, smartboard. All right. So compare sides that match up. So what I see is the X. So this part, the X, I'm going to do X over 15.
Wait, were we supposed to do number 8?
Did the direction say not to?
It said odds, I thought.
Yeah, I said odds, do the odds.
Yes,
Oh,
that's
yeah,
right.
I did them all on accident.
You didn't have to do this one. Okay, so why don't we go over number 9? And then if we have time at the end, we can go over this one. Okay, number 9, on ground level, the base of a tree is 20 feet from the bottom of a 48-foot flagpole. Okay, so we've got, this is 20 feet from the tree to the bottom of the flagpole. Okay, and then the flagpole is 48 feet long, or 48 feet tall. And the tree is shorter than the pole. At a certain time, their shadows end at the same point, 60 feet from the base of the flagpole. So that means this entire distance is 60. Okay, so if that's 60, this piece has to be 40. Do you follow so far?
Yep.
Okay. At a certain time, their shadows end at the same point, 60 feet from the base of the flagpole. How tall is the tree? So we're trying to find how tall is the tree. Okay, so we've got 2 triangles going on here. And what I like to do, I like to kind of recreate those triangles separately. So the smaller triangle, we have 40 and T. On the bigger triangle, we've got 48. And then the 40 plus 20, which is 60. Okay.
Wait, why? Never mind, sorry. I was thinking about the section between the flagpole and the small tree, and so I was going to ask why it was 60 and not 20.
Well, because it's that entire distance. It's not just from the tree to the flagpole. That makes that bigger triangle. Because this would not be a triangle, right?
Yeah, that's why I was confused. Thank you.
Mm-hmm. So now we just compare sides that match up. So T over 40 equals 48 over 60. You cross multiply, you're going to get 60T. And then 48 times 40 is 1,920. Divide both sides by 60. And you should get T is 32. So that's 32 feet. Okay. On number 11, you kind of had to use A in order to find B. So I'm going to go over A and B. I know whoever asked about this question, you were asking about part B. But basically we have similar triangles here. And this is a right angle. The first question is asking, what is the distance between the parks through town? Okay, so that's asking about this distance right here. I'm going to call this X. That's what part A is asking. Okay, so if we compare that to the other triangle, X lines up with 1.4, right? Okay, and then if you compare other similar parts to the triangle, we'll use a different color. We see that we've got the 7.5 and the 1.2. Those are both side links. The 1.4 and the X are kind of like the base, and then the 1.2 and the 7.5 are the side links. So those match up. And we'll keep that consistent. Okay, when you cross multiply here, you're going to end up getting 1.2x equals 7.5 times 1.4. Should give you 10.5. And then you divide by 1.2, you get x is 8.75. So that tells you this is 8.75. Part B is asking you, sorry, not 7, 8.75. And that's miles. All right, so part B is asking you, what is the distance from part A to part B through point R? Okay, so if we had to go from A to R, then you had to go B to R. You're adding those two distances. So you're going from point A to R to B. So what you end up doing is you're adding those two side links together. From A to R and from B to R, you're adding those two together. Does that make sense? Do you understand what the question is asking you?
Yes.
Okay, so we're trying to find A to R plus B to R, but we don't know those, right? So what you have to do is you have to use the Pythagorean theorem. This is a right triangle. This is a big right triangle. The hypotenuse is 8.75, so that's our C. We'll call this side A, we'll call this side B. A squared plus B squared equals C squared, and that's how you set it up. Let me extend the page, I'm running out of room here. So we don't know what A is, so I'm just going to say A squared plus 7.5 squared equals 8.75 squared. Okay, so what is 7.5 squared?
56.25.
We have A squared, that's that. And then what is 8.75 squared?
76.5625.
Okay, so then we're going to subtract that. You end up getting A squared is, you end up getting something like 20.3125, something like that. And then you take the square root of both sides. You get A is around 4.5. So that tells you this distance is 4.5. And you know that BR is 7.5. So when you add those two together, you get 12 miles. Okay, any other questions? Okay, I want to quickly, okay. And if you decide later on that you want to stay in this meeting a little bit longer, when everybody else leaves and you need extra help, that's fine. We can go over some other stuff. But I wanted to quickly kind of highlight, so I have a video for you to watch today, but I kind of want to go over some of that with you. That way you hear me talking and not just the other teacher who's teaching this. Today I wanted to look at dilations, and you've kind of had some experience with that, but some real world examples are here. So when I think of the word dilation, I automatically think of going to the eye doctor when they have to dilate your pupil so it looks like this, and then you have to wear those silly glasses and your eyes hurt for a couple hours. But anyway, that's what I think of when I think of dilating. I think of my pupils getting bigger, okay? But it can go the other way. You can get bigger, you can get smaller. Okay, so what this means for geometry is when you have a pre-image and an image, when you're trying to find the scale factor, it's dilating from a center. It's getting smaller, it's getting larger. Okay, so in this picture, do you see that the new image has the prime marks? Okay, so the new image is in red. I'm gonna put new here. Okay, and then the old image is in blue. Okay, so this is getting smaller. Can you see that going from blue to red? It's getting smaller. So we would call this a reduction. Okay, and how you find the scale factor? It's also known as K. K is known as your scale factor. You find this by using this fraction, the new distance from the center over the old distance from the center. So in this scenario, the new distance to the center the center is at C, the new distance, so P prime would be 2. So that new distance would be 2. The old distance would be what? From C to P, which is just 3. So that scale factor here is 2/3. Okay, anytime you have a scale factor that is between 0 and 1, that is a reduction. Okay. And it's an enlargement if K is greater than 1. Okay. And this is all based off, the distance your point is from the center. So let's do another one. So here, this is the official, definition of a dilation. This is kind of what I went over in a nutshell. But an enlargement is a dilation with K greater than 1. A reduction is a dilation with K between 0 and 1. So it's a fraction between 0 and 1. Okay, so this is an enlargement. So the prime marks indicate your new figure. Okay, and then if it doesn't have any prime marks, that's your old figure. Can you visually see that going from blue to red, this figure is getting larger? You should. Because if we calculate the distance, what is that? New over old. So the new distance is 5. The old distance is 2. So that would be your scale factor. That is greater than 1. So that's an enlargement. Here on the other side, we're going from blue to red. It's getting smaller. From P to P prime, you're getting smaller. So this is a reduction. Okay. Really quickly, we have more of the same. I want to show you what this looks like on the coordinate plane. So if we have, I'm looking at this one, I'm going to try to make straight lines with my smartboard. We'll see how this works. And red. So this one is asking you, find the center of dilation. Where is it dilating from? What point? So how you do this is you have to connect your A prime, your B and your B prime, your C and your C prime. Where all of those lines connect is the center of dilation. So I'm going to connect A and A prime and extend that. I'm going to connect B and B prime. Well, shoot. Smartboard's a little off. I'm trying, guys. I'm trying. There we go. Connect B and B prime. It's not perfect. And then connect C and C prime. Can everyone kind of see where this is headed? Okay, so all of these points intersect where? They all intersect at point, go ahead.
At point 1, 0.
It's going to be 0, 0 actually. Yeah. So that means these lines are concurrent. That means you have 3 lines that intersect, 3 or more lines that intersect at the same point. So the center of dilation would be 0, 0. And you can't see that. Okay. One more question I want to go over is, what if you have this scenario and you're given the scale factor and it's asking you, you've got your pre-image points. So these would be your pre-image points. And it's asking you to find the points to your image. All you have to do, because the center of dilation is at the origin, all you have to do is multiply each of these numbers by the scale factor, which is 1/2. Okay. So what is 2 times 1/2? What's half of 2?
1.
1. So half of 2 and half of 2 is 1, 1. Half of 6 is 3. Half of 2 is 1. Half of 6 is 3. Half of 4 is 2. Half of 2 is 1. Half of 4 is 2. So we took and we multiplied each of these numbers by the scale factor, which was 1/2. That's how you got your new image points. Okay. Same thing on the next question, and the video goes, she goes over all of this. I just wanted to touch on a few things so you hear it from me. For this one, you're multiplying all of those points by 3. Okay, so if we've got A is at 3, 6, B is at 6, 4, C is at 3, 2. Your new points are going to be A prime, B prime, C prime. And you're going to multiply everything by 3. 3 times 3 is 9. 6 times 3 is 18. 6 times 3 is 18. 4 times 3 is 12. 3 times 3 is 9. 2 times 3 is 6. I took each of those numbers, multiplied them by the scale factor, which was 3. I can do that because the origin is my center of dilation. And sometimes, like this question, you might have to set up a proportion. And that works the same way. So what we were dealing with in the previous slides was, the distance it is from the center. the new and the old distance, but sometimes you have to compare the new figure side links and old figure side links. So for this one, you know, again, that the scale factor K is just new over old. Okay, so the new one is this right here, the smaller one. That's the one with the P prime. And the old one is the bigger one. So we are getting smaller here. So would this be an enlargement or a reduction? Anybody?
It would be a reduction.
Reduction, good. Okay, so all you have to do here is compare side lengths. So we have new over old. So a new side length would be 5. An old side length would be 12. Those match up. Okay, so this would be your scale factor, 5 over 12. And it says to find X. You have 2 different ways to do this. So we can multiply our 6 times our scale factor, which is 5/12, and get X, or we can simply set up a proportion comparing sides that match up. I like doing the sides that match up. So I'm going to do 12 over 5 equals 6 over X. So 12X equals 30. When you multiply those out, divide them, you get X is 5/2. Okay. And on the last page, you're given a graph here, and you just have to pick out what those points are. Multiply each of those numbers by 3 because your center of dilation is your origin. Okay, it tells you that in the directions here. On this last problem, same kind of scenario, but you're going to have to use the distance formula here because we have diagonal lines. Okay, so to find this distance, you're going to have to use the distance formula to plug in these 2 points. Find the distance between these 2 points. Okay, and then the video that's attached to this lesson for today, she goes over everything I just touched on, but in a little bit more detail. Do you guys have any other questions for me? Okay, I'll take that as a no. What I wanted to look at is your assignment for today before I leave you. If you go to modules, today is Wednesday, we're doing dilations, and this is your assignment. Well, these are the notes, and the same notes that I just looked at. These are the same notes that are in the video, and then you need to work on this worksheet, okay? It's due at 11:59 p.m. Please neatly show your work. Do not submit someone else's paper as your own. I can see that. You know, if you turn in the same paper and I see the same paper, I'm going to recognize it. So you have 14 questions to do, and it's just a picture upload for today. I'm going to turn that in here. Any questions?
No. We don't have to print this, right?
No, you don't have to print this, but you can. If you, as far as submitting your homework, what you can do is take a picture of your work on notebook paper.
Okay, thank you.
Michael, did you just, are you?
Yeah.
Hey, so my computer is supposed to ding at me when people are in the lobby. It didn't ding at me, so I'm going to send you a recording.
A recording.
Yeah, of what we just went over. because I was at my board, I couldn't see my computer screen, and it didn't let me know that anybody was waiting.
Right.
Okay, so I'm gonna,
Miss,
yes, go ahead.
sorry.
If you
Where
don't have
is
any questions, you can go.
Miss Richards?
Uh-huh.
Where is the worksheet?
Okay, so it's attached, everything is in that one page under modules. So if we go to modules,
Mm-hmm.
go to dilations page for today. Nope, that's what.
Because I pulled up the assignment and it was blank.
Cool. Let me see what it did. So when you pull the worksheet up, this,
I clicked 1/20/21 homework assignment upload dilations and it says no content.
right, that's where you take a picture and upload.
Okay, so where am I finding what you're at?
If you go to modules,
Yep.
under Wednesday, the 20th, January 20th,
Mm-hmm.
click 1/20/21 dilations,
Okay.
and then scroll all the way down.
Oh, my computer's freaking out. Sorry.
It's okay.
Oh, I found it. Okay, we're doing all of the questions.
Yes, ma'am.
Okay, and they're due
Yep.
tonight or tomorrow.
Tonight.
Okay, thank you.
Uh-huh.
Bye-bye.
Bye. Did I have any other questions? Michael, did you have any questions?
No, oh,